It's just great to be here. It's just amazing to crawl out of my basement finally, to be here, to meet humans, to hug, to shake hands, to have a meal together. I'm almost in tears. This is just absolutely amazing. So I want to start by asking you to give yourselves a hand for being here. So this is amazing. So thank you so much for being here. This is absolutely phenomenal that we can finally get together, we can learn from each other, and there's no better way to spend our lives than enriching ourselves in the spirit of learning and furthering our field. So it's great to be here. I can't say it enough. I want to talk about agile development. Well, I go to companies, and one of the first things they want to tell me is, they say, Venkat, we want you to know we are agile. And I often say, I'm so glad we got that out of the way. Now let's talk about what we actually do. So agile is this one word everybody talks about. So I want to ask the question, what is it really to be agile? It's got to be that stand-up meeting, isn't it? Because we do that every day. And one thing I figured out, humans love rituals and ceremonies. The reason we love rituals and ceremony is that rituals and ceremony give us relief from reality. We don't have to do the real stuff anymore. So it's got to be the stand-ups, isn't it? No, it's not. Well, maybe it is really Scrum. It's got to be, right? No. Well, then what is it? Maybe it's the velocity, right? Because that's so important. It doesn't matter what we do, but we got to be doing it faster. Maybe that's not it. Well, then I kept struggling. There's got to be something. I think I finally figured it out. It is hiring the Scrum Masters. That's what it really is, isn't it? Unfortunately, that's not either. Well, I remember this one experience I would never forget. I have this problem. No matter what I do, in the back of my mind, there's a thread that keeps thinking about programming and software development all the time. That's my problem. But I was having a good meal with my family a few years ago, and as we were having food, the background thread reminded me of something. So I pulled up my phone, started typing something, and my son, who was sitting next to me, leaned over, looked at what I was typing, and he said, Dad, no, you don't dare tweet it. And of course, one thing you know in life is, as a parent, your first job is to embarrass your children all the time. So I said, well, since you don't want me to tweet it, bam, here you go. He's like, oh my gosh, I can't believe Mom, Dad tweeted this. Well, that was probably one of my most infamous tweets ever, because I never expected this to be retweeted so many times. And I said, I've set the wedding date. I've not asked her out yet. How software projects are managed. This is unfortunate, isn't it? This is how a lot of projects are actually managed in the world. And the beauty of what it is today is we call it agile. And the question is, if you decide what you want to do and plan everything ahead, then what's the point in even claiming that we are agile? And it's very frustrating when you see organizations do this over and over and over. So we want to really rethink about agility in terms of what we do. And there's no better story than that, I think, than looking at Java. But what is really agile development? I'm going to say fundamentally agile development is really feedback-driven development. That's what we really are after. We want to be able to develop something based on feedback. Now, if you ask me, one of the beautiful things we humans celebrate and benefit every single day in our just essence of living is that feedback. And without feedback, we don't survive. It's just impossible for us to do. Reminds me of my very first trip to the Grand Canyon back in 1993. I've been there several times. I hope to be there several more times. And as you know, Grand Canyon is not a mountain. It's a hole on the ground. And I started driving from Phoenix over to Grand Canyon. I was about 2 hours into the drive approximately. And now I was like, not sure. Am I going in the right direction? And I pulled over on the side of the street, and I looked around 360 degrees. There's nothing other than desert all over. And I said to myself, I've got two options. I can turn around and start driving back to where I came from and ask them, was I going the right direction? And they say, yes, you were, and I can turn around and drive again. Or I can keep going, not knowing if I was lost. And I was not sure, what should I do? And you would ask, oh, Venkat, come on. Were you not responsible to carry a map with you? Oh, certainly I had a map with me, no problem at all. But you know what that map was missing? That one thing that was not on the map, you know that, right? That blue circle on it. And that is the difference today, isn't it? I can have my GPS on my mobile device. I just start driving, and it tells me a very important aspect. Not how far I've been, that doesn't matter. It tells me how far I do have to go from here on. And that feedback loop is exactly the essence of agile development. Imagine having the GPS on your projects to know where you're going and where you should be going. That's what you really are after. Well, Java, of course, is a great experience to learn that from. And that's what I want to talk about here today, about my feelings about Java and what I think about it in terms of the evolution of the language itself. But one of the beautiful things about Java is, it's been around. Java is unbelievable in terms of a language that has survived this long. Can you imagine a language that survived this long? Can you imagine a good language? Let me rephrase it because somebody says JavaScript. It's like, no, no, no. Can you imagine a good language that survived this long in terms of how powerful this language is 27 years later? And unbelievable. But I'll be absolutely honest and frank with you. If you ever go on to YouTube and look at some of my videos from back in, I'm going to say 2006, 2007 time frame, I was that person on the picket line constantly saying, Java is no good, Java is too slow in evolution. And I'm not even making this up. This is true. I've saved those emails. I've gotten quite a number of emails that literally said the following: Venkat, I hate you because you hate Java. Apparently, you shouldn't be hating a programming language. Well, but that was me. And of course, all that changed for me with Java 8, I became a huge fan of the language. And of course, Java started moving forward, and I was excited at what was happening in Java and how things were evolving as time went on. And that absolutely changed my feelings about Java, and I started singing its praises for a good number of reasons. But of course, back in time, it was a very small, slow pace of development. And if you really look at Java in terms of the evolution of the language, you can see that 1.0 released in 1996, and then 97, and then 98, and then 2000, and 2002, 2004, 2006, 2011, 2014. Now we can see what's supposed to be a 1-year release became a 2-year release, a 3-year release, a 4-year release, and it kept slowing down. Now, why was the releases slower and slower and slower? Part of the reason was that when they decided to plan what was going to be in a release, think about this for a minute. You are announcing what will be in a release before any work has been done. And then you tell the developers, go work on these features. And they're working on it. And then you go to them and say, how's it going? And you and I know this as developers, right? What is our response all the time? We all often say, it's almost done. And the it's almost done usually is 3 years later. And unfortunately, the problem with that kind of managing projects is that we face delay after delay after delay. That did not make any sense. Well, that was the state of Java back in time. But then they made absolutely a brilliant move, which was received by great amount of suspicion and not a welcoming change for a lot of people, because we often fear change quite often. But Java now, of course, is moving at a very rapid pace. And we can see there's a 6-month release cycle. And we look at this and say, oh my gosh. And I've heard people say, my gosh, 6 months release cycle. How could it be good? How could it be reliable and so on? Well, sure, there's suspicion that's natural. And it's good to have a bit of a suspicion as well. So we often wonder about it. Well, Java is not being developed on a 6-month cycle. That's important to keep in mind. So the features that are in Java, just take one example. The feature in Java 10, which was type inference, it literally took them 5 years to develop it, not 6 months to develop it. The feature in Java 19, a pre-release feature, has taken them 12 years to develop it, not 6 months to develop it. So Java is not being developed on a 6-month cycle. It's important for us to keep that in mind. But then what is the biggest change in Java? Well, a few years ago, I turned 50 years of age, and I was on a train ride from Krakow to Torrent to speak at the Java user group. And this was a morning, afternoon train ride for me. And as I was kind of looking through out the window, I said, hey, I'm turning 50 this year. What do I want to do? And suddenly I had a insane idea. And I said to myself, what would it be like to speak at 50 Java user group when you turn 50? And so immediately I texted my wife and said, I've got an idea. What if I go speak in 50 Java user groups this year? And I really thought she would say, you madman, get out of the train. And instead she said, what a great idea. And the next thing you know, I blogged about it, and within a matter of days, I had almost a 50 user group asked me to come and speak. And the 50th of them, I'm absolutely thankful and humbled about it, was actually on the top of the Eiffel Tower, and that coincided with the Paris Java Users Group's 10th anniversary. And so that was an amazing experience. But in this journey of speaking, I think in the end I spoke in 52 user group that year. And in that journey, one particular week was interesting and more challenging than others. And that week, I was going to speak at 6 user groups in 1 week. And I was going to speak in multiple cities in Switzerland and then hop on to Germany and speak over there. So I was a bit nervous. It's like, oh my gosh, I'm going to be in different cities every day. How's this going to work? And when I landed in Zurich, I got picked up by the leader of the group. And Marcus is an amazing fatherly figure. He picks me up at the airport and says, here you go. And he hands me a folder. And he says, in this folder, you have tickets for every day's travel. And that tells you that you can go from this city to this city, this city. And he planned out everything. And then he said, well, the train leaves at 10 past an hour or at 40 past an hour. And this ticket, you can take it to travel any time during the day. There's no restrictions. I have a flight tonight, and I cannot tell you how many times I keep thinking of it. Because if I don't make the flight, I won't be there in time tomorrow in Poland, right? And flights are nerve-wracking because you have to be on time. You got to take that, I always am nervous about travel in spite of the fact that I travel frequently. But that week was the most relaxing week for me because I would wake up in the morning, I would do some work, I would go jog, I would go have a nice breakfast, then I would drag myself to the train station, and I would find somebody interesting, I would chat with them for a little bit, and then I would say, I think I should really take a train. And I would say, I can take either this train or one in 30 minutes. It doesn't matter which one I take as long as I have enough time to get to where I want to go. So there was a train leaving every 30 minutes, and it doesn't matter which one I took. And this is exactly what Java is doing today, is it's telling the developers behind the Java language, here are the features you want to work on, but put your best efforts towards it. And when you're done, when you think it's ready, you can release it. And you don't have to wait to synchronize with all the other features. And you can get on the train that's leaving in March, or you can get on the train that's leaving in September. And if that's not right, you can leave on the next March train, and there's a train leaving every 6 months. And what is that called? True agility. That's the beauty of what they are doing. And this is absolutely phenomenal in terms of how they figured this could be done. And what is even better is that ability to actually make that change. How many of us will have the courage and the ability to go from what we do to what could be done differently when there is enough suspicion around us? And that's brilliance in my opinion. And not only that, is not to commit to the features until we know that this is going to be really useful. And that is phenomenal as well. And as an example, in Java 12, well, we had anticipations for looking at a raw string, And about, what, 3 or 4 weeks before the release, that was gone. It's like, oh my gosh, where is it? And of course, they decided to rework on it and bring it back as a text block because that, of course, gave us a much better experience in terms of what we do. And that really came from feedback, if you will. Similarly, they changed the keywords around. The keywords changed, for example, in terms of how we work with a switch and not a return, but a yield. That came from feedback from the community. And going back forward to a pattern matching, to really be using a when clause in terms of providing a guard, a lot of these are feedback driven. And imagine having a pre-release where you can experience, you can use it, you can provide feedback, and then you can be part of guiding the language in its evolution as well. That is absolute brilliance in terms of what we can do with it. So to me, the true agility really is to decouple the development of the app, the language and everything around it from the release cycle. And a lot of times when we talk about agile development, we are fairly misguided. And we tend to really focus on the wrong things. But finally, it's rewarding to see an organization, a group of people who said, let's rethink about this. So the whole purpose of the release cycle is not about you and me. It is really to make Java much more releasable on a timely manner and to bring agility into the development of the language itself. I think that's sheer brilliance. So Java is not being developed on a 6-month cycle. Java is being released on a 6-month cycle. And that's a huge difference in terms of how we want to think about Java as a language, as a platform, as an environment. That is absolutely important. And when we realize that it's not being developed on a 6-month cycle, but it's being released on a 6-month cycle, it gives us a whole new confidence in saying, this is not something that's being rushed into. This is not something that's being released in a hurry to say, oh my gosh, we got to release. And some people say, oh my gosh, look at this release of Java. There is not a whole lot in it. And I said, that's good, because it doesn't have to be. You want to focus on quality. And if you forget about quality, the cost of development increases. And the problem is, with respect to Java, it's a lot more difficult than a lot of other environments we see. And I speak in no disrespect to any particular language. I love programming languages in general. But a lot of different languages don't have the luxury that Java doesn't. And the problem is, some other languages can innovate rapidly. And they can try ideas and say, what do you think? And 2 releases later, they could say, never mind, we want to remove it. And the developers using the language love that. They can go and change all the code all over again. And they're like, this is great. Well, unfortunately, developers behind the Java language know that programmers using Java don't have that luxury a lot of times. Java is one of the most widely used languages. It's used by more than 10 million developers, used by so many thousands of organizations. Banking industry and so many other industries rely upon it. And stability is extremely important. And when you and I work on legacy software, when somebody comes to you and says, make this change, you only have 2 options when you hear that, isn't it? To laugh or to cry. And sometimes we prefer laughing than crying. And they say, what are you laughing about? They wanted this change, right? Because we know what happened the last time we tried to change something like that in our product. It's incredibly difficult. And think of Java, one of the most widely used legacies out there. The word legacy is a funny word, by the way. I was talking to my dad the other day, and he said legacy, and I laughed. And he said, you're laughing. I said, I'm sorry, Dad. The word legacy really made me laugh. And he said, what's wrong with the word legacy? I said, well, that's a different story, right? Legacy means good things in human lives. It means something completely different to us programmers, right? Because we don't like legacy. If somebody says leaving legacy, you're like, oh my goodness, no. I was working with a client in the UK, and we were talking about a code change we have to make and a design decision they had made. Oh, by the way, it was a legacy application. They had developed it over the past 20 years. And they had made a design decision about 10 years earlier. And that decision resulted in them having to change code that's going to take 7 months. And the manager was sitting there and saying, I thought you would come and say we can do this next week. It's going to take us 7 months of change. I'm like, yes. And he's looking at it, I can see why it's going to take some time. And I looked at the architect and said, why did you guys do this? And he gave the answer I get often from developers. His first response was, Venkat, you should know, I was not here when they did this. Right? This is the first answer you get all the time, right? I'm the victim, right? You should know this. And I tweeted that day saying, technical debt is the gift you give future developers, right? And imagine that for a minute from the point of view of Java for a second, right? We complain about legacy code we have to deal with. Java is the biggest of legacies out there. And imagine you have to move Java forward compared to all the other things we do. That's a phenomenal, it's a Herculean task if you really think about it. And so from that point of view, it is something that takes the time, and how do you decouple that to bring agility is really the sheer brilliance in my opinion. So with that said, let's think a little bit about what we have been through and what are really possible for us and how we can really enjoy this. So let's think about some of the features in which Java is really brilliant, and I see this as a brilliance. Now, when it comes to adding these features, the folks behind Java, like I said, being a legacy, they're not infatuated. They're not jumping in and saying, let me go shopping. Let me see what I can bring in today to Java. That would be really a disastrous path. They can just put something into Java and then pull it out later on, like I said before. And the reason, like I mentioned, is that Java is used by 10 million developers. Well, you got to think about this for a minute. When you have 10 million people using your language, and out of which 1 million people know where you live, you have to make decisions very differently. So they don't have the luxury to add a feature today and remove it tomorrow and change it. So instead, they're asking 3 very fundamental questions. And the first question they're asking is this feature really useful for Java developers? We don't want to bring some feature in just because it seems exciting. Is it really useful for Java developers? Is it going to make them productive? That's the first question they're asking. The second question is it feasible to implement it? Well, we find this is useful, but is it even feasible to implement it? Is it going to work? And is it going to work really well? What are the consequences on the performance? What's the consequence on integration? What's the consequence on backward compatibility? And the third question they're asking, which is even more important, is what other features in the future will this make it harder to implement? So it's a very thorough investigation into introducing features into the language. It's not driven by infatuation or by market pressure or people like me loudmouth saying this is not enough, but they're taking the time to really investigate and determining if this is useful to developers, is it feasible to implement with enough backward compatibility, and what is going to happen to the future of the development if you bring this in. And so it's a very thorough set of steps. And to me, the innovation in Java is very different from innovation in other languages. Let's take an example here for a minute. Suppose I want to really say here, let's say I want to call a function called greet, and I'm going to say devox over here, and basically run a devox, greet over here. So if I'm going to run this particular greet request right here, what do I want to see within this particular function? So I'm going to say right here, let's return a string, we'll call it greet, and we'll take a name right here as well. And what do I want to say within this code? And I'm sure everyone has written this code many, many times, right? You say string message is equal to hello, and we will fill in the name a little bit later. And then what do you say? You say return, and I want to return the message at the very end of this, right? That's a string you want to return. But I want to say message plus equal to, and I'm going to say, in this case, great seeing you. And I'm going to then say message, let's say, plus equal to, and thanks for coming. So we all have written code like this before, several times over. But let me ask you, in all earnesty, would you put that on the resume? Would you say, I have 17 years of experience using plus equals? This is the code you hide from humanity. You won't show this to mom, right? As a proud code, look what I wrote today. And she's like, really? This is not something you would show the next generation of programmers. I mean, if you got kids at home who are running around and playing, right? What's going to happen if they come over and look at this? You're going to hide this from them. Because they look at this and say, that's what you do for a living? I can't tell you how many times people ask me, so you have children? I say, yes, I do. And the next question, are they programmers? I'm like, no. Really? I really wish people told me this when I was younger. I would, go home. As I'm coding, I would take my children, put on my lap, and I would be coding. And kids, they don't know much. They sit there, play with it. They'll bang on the keyboard occasionally, define some variables for me. But as time went on, you don't realize children actually are observing. And my kid was looking at the code one day, and he looks at the code, looks at me, looks at the code, looks at me. And then he says, Dad? I say, yes. He said, don't worry. I'll grow up one day and take care of you. You don't have to do this. It's strange when we write bad code, right? So we don't have to be writing code like this. We can be proud of it moving forward. So the point really is, thanks to text block. Well, text blocks is not a new idea. Here, docs have been around in other languages for a while. We can definitely make use of them. But in this context, of course, we can simply say, hey, I want to go ahead and start with a little hello, but I'm going to use a text block to define it. I don't have to be sitting there and writing all that verbose code. I can make it really concise and easier to work with as well. I don't have to struggle through them. So essentially, in this case, we can start by defining a nice little string, as you can see in here. So we can say string message is equal to hello, and great seeing you, and thank you for coming. So we can start defining these variables as a string, which is, again, a brilliance of text blocks. You may wonder, how does this really behave under the hood? It's just a string. And it's entirely a compiler feature, nothing internal to the implementation. And that's one of the brilliance of this. I want to make sure I'm using the right version here. So essentially, that is one of the biggest developments here is we don't have to struggle through to use some of these features. It becomes really, really easy for us to work with. Let's figure out what I'm doing here. It says missing a delimiter on this one. So essentially, the idea behind this is you can start writing code with a lot of verbosity gone, and you can simply make it work and make it elegant and very simple. So essentially, I can define a message right here. I can say a string, let's say a message is equal to, and you can simply start defining text blocks without much of an effort at all. So I could say, for example, hello, and I could say, great seeing you, for example. I can write multi-line strings without much difficulty at all. And of course, I can start filling in details into the code along the way as I choose to, and I can start putting in different, and the beauty of this is, hey, what about performance? What about interoperability? What about? Well, one of the things we benefit from Java is the ability of strings to be interned. You get that benefit as well with strings. But again, like I mentioned, heredocs is not a new feature. But in all honesty, I've used heredocs in other languages, and they work most of the time. Occasionally, I would spend 15, 20 minutes of life just trying to get the heredoc to work in the way I want it to work, which can be really frustrating. And the beauty of this is, really, in this case, the ability to have a very smart indentation. So for example, Java compiler takes the time to figure out that indentation is not intentional, it is incidental. Whereas that indentation is actually essential. So it knows to indent the code where I want to and not where I don't want to. So essentially, in this case, you can see the hello and the thank you are not indented at all, but the great seeing you is. And again, when I see features like this, I absolutely love it because they think about me, the developer, rather than their convenience in writing the code. That to me is a great innovation right there we can benefit from. So, of course, this came out of development that took quite an effort. And again, from feedback-driven development, asking how this should be done and bring that in is absolutely brilliant. Similarly, again, features that we may have seen in other languages, but it's the Java way of doing things is just absolutely phenomenal. For example, let's say we have a process function which is going to take an object, which is going to take an input coming in. Well, let's take a look at what we're going to do within this function. So I'm going to say, in this case, a process, I'm going to pass a 1. I'm going to call a process and pass, let's say, a hello right here in this particular case. So I want to go ahead and call this particular function. Again, looking at the evolution of the language, if you think about it, I can say if input is an instance of, let's say, integer, what do I want to do? I could say return, let's say, got a number. That's all I want to say for now. Otherwise, I'll simply say return whatever for now. Let's start with those baby steps. So got a number and whatever. But then I could say if input is an instance of, let's say, a string. And then I say return, let's say in this case, got a string. Let's start with that. So it says got a string, but I want to really know, got a string of what did we really get over here? So, okay, this is going to be instance of well, string. There we go. Try that again. Okay, someday I'll get this right. There we go. So essentially, got a string. So this, you say, okay, but I really want to know the length of this particular string. So you say length is equal to, and you want to print the length, let's say here, very quickly. And in this case, I could say input.length. Will that work? No, I heard you say no. And if you try to run this code, what does Java say? It says variable length. Well, of course, it's a method, right? No, not really. So it says method length variable on input of type object is not found. And you're thinking, why doesn't that work? And Java says, no, let me tell you what to do. You got to say string, and you got to say the input, right? That's the way we did this in Java, right? That's the way things are done around here. And then we put this around, and when you finish that, Java says, that's good. Anyone remembers what this feature is called? That's right, you said casting. I call it punishment. I mean, how would you feel if people around you are like this? Maybe you see a colleague who is stepping out the building in the evening, and you ask them, where are you going? And they say, you know what, that movie, I've been waiting to see. I'm going to catch that tonight. You say, have a good time. Next morning, you see them at breakfast, and you ask them, hey, how was the movie? Oh, did you go to the movie? And they say, yes, I did. And you say, how was it? And they say, how was what? And you say, really? You're probably going to quietly walk away, right? Because you want people to carry a context in conversation. Did you go to the movie yesterday? Yes, I did. How was it? Say what you want. But the it, of course, is the movie. So this is not really helping us. Well, thankfully, we have I call it smart casting because that's what I heard from Groovy and Kotlin and other languages. But you can say stir, and in this case, you can simply come around to this particular code. And you can simply say, for example, without all the noise in there, you can say stir.length. So I always want to ask the question, and in the past to the now, so do you work for the compiler, or does the compiler work for you? And in the past, I have a feeling we were working for the compiler. The compiler comes around, how's it going? I'm trying to keep up. I'm writing. Work harder. I'll check back on you after lunch. And the compiler leaves the building. Well, no, I want the compiler to work for me. I don't want to work for the compiler. It feels like we can focus on getting our work done than pleasing the compiler. And I absolutely love when a language can evolve to make my life more productive as a developer. And so that's basically the pattern matching with instance of, but taking that further in, we can start benefiting with a lot of other things that we can do as well. For example, let's say I want to go ahead and say a new output, let's say a new person. And I want to say a person I want to create right here, let's say Alan and let's say Turing. And in this case, I want to create a person class. So we say class person. And then what do? Define a field for first name, right? So you say private string, maybe first name. And then you have to create a last name field. And then what do? You have to write a constructor, isn't it? And then you have to write a getter. And you keep writing all this code, which is great if you get paid by the number of lines of code you type. And I know what you're thinking. But Venkat, that's not fair. We don't do that. We only define this field, and we gently right-click on it. And before we could blink our eyes, the IDE vomits the rest of the code for me. But that vomit in unerasable vomit, and you have to look at it every single day when you look at it. Like, why? Why should I go through that pain of doing things? I want to get my work done, not sit there and keep typing away code. So class person, well, how about saying a record person? And I'm going to say here is a string of a first name and a string of a last name as well. And I can simply execute it. And it even is intelligent to give me some information about the toString written for us to give us something meaningful. And what is the beauty of a record is, with records, you have a deal, a really good deal. It's called the buy one, get 5 free offer. I mean, who could beat that kind of an offer, isn't it? Just buy one and you get 5 free. You just buy a record and you got a constructor, a getter, a equals, a hash code, a toString, all that given. And as a bonus, this is going to become really easy to use with the pattern matching as well. And that absolutely makes our life a lot easier. So with that said, of course, we can see the benefit that we are getting to by writing a lot less code to achieve a much better results in this regard. But that takes us to the ability to do pattern matching with some of these concepts as well. With the pattern matching syntax, we're not writing code that's verbose and boring, and we can write code in a very mature way. You know, honestly, when I write code in about 15 different languages, and every time I write the code, my job is to sit there and get something working and then take the time to refactor it. But I remember almost every single time when I write a code in another language, I would write the code and then spend the time refactoring to make it really elegant using a pattern matching syntax. And I really, really love pattern matching. And to see that actually available in Java is just absolutely mind-blowing. And we can absolutely benefit from that really nicely. For example, going back to the example we saw just a few minutes ago, we could have written that code with the process like the way we did. And in this particular case, we can simply turn all that noisy if and else statements can go away. We don't have to really do this. Now, that brings us to one thing we want to think about. And sometimes we could be programming for decades and not even realize it. And that's what I love about programming is, even though I've been programming for decades, I would wake up one morning and say, wow, I'm getting a better understanding of this than I did before. And one such realization for me was the distinction between statements and expressions. Statements are kind of grim. They have to force you to do mutation. Statements don't return any results. Statements are rude if you think about it. You go to a statement and say, here, please do this. It says, I'm done. You say, what happened? I won't tell you. You go find it for yourself if you want to, right? I mean, who wants to work with a statement, right? Not very cooperative, not very friendly. Expressions. Just say the word expression. Feels better already, isn't it? Expressions are beautiful because expressions return a result back to you. Expressions don't force a mutation. So one of the first evolution, of course, is from being a statement, a switch is an expression. So you can say return a switch, and in this case, of course, you can say input, for example, And in this case, I'm going to simply start with a default and let's do a whatever as we did before a few minutes ago. So we'll start with this as an expression. Oh, by the way, here's a little secret for you. You can easily tell a difference between a switch statement and a switch expression because an expression has a semicolon in the end. Isn't that cute? So this is basically returning a whatever as a response. But I can say a case, and I want to say this is going to be an integer that I'm interested in, and I could say I got a number. So this is going to be using a syntax to provide us a result of an integer, or I can say here is a string, again that pattern matching with instance of is nicely merging in, and we can say got a string of length, and of course I can then say, for example, stir.length just to scratch the surface of this beautiful feature. So this becomes really easy and elegant too, and of course because it's an expression, you're not mutating things unnecessarily. Well, if you ask me, what am I really excited in this journey that Java is going through? You know, sometimes we are too close to things and we don't see it. And this is metaphorically speaking, right? Sometimes we learn things from life. Sometimes we are too close, we cannot see it. But if you step back a little bit, you got a better view of things. And to me, one of the things we should do as developers is to stand close to the features, but step away to really understand and to be able to, form an idea of where things are going. So for a few moments, I will ask you to step back a little bit and look at it, think about it. I want you to think about a few things that's happened in Java over the years and where it's going. So in the past, in the really, really distant past, the structure of, if you think about, imperative style, parallel code was very different from the structure of imperative style sequential code. Most of us will remember this, right? So the structure was very, very different. If you wrote the code using imperative style, and then you modified the code to make it into parallel, what happens? The code turns into a monster, isn't it? How do you know you're working with the sequential code? I'll tell you, very easy to know this. You go to work and people actually smile at each other. That's when you know, right? Easy to manage, easy to maintain. Then the code becomes a monster and the structure is very, very different. It's very difficult to manage it. But on the other hand, think about Java 8. Java 8 did two phenomenal things. And the first is, in Java 8, the structure of, you could say, a functional style parallel code is the same as the structure of, functional style sequential code. This was, of course, thanks to the Streams API. And this made a huge difference in how we wrote code with functional style, reduced complexity, easy to reason the code, easy to change it as well. But also in Java 8, the structure of functional style, asynchronous code is the same as the structure of functional style, synchronous code. And then, of course, this is thanks to completable future. And this is, again, a phenomenal advantage in terms of writing the code in almost the same way with this particular construct. But notice what's missing in this entire thing. What about imperative style? So I'm a big fan of functional style of programming. But I would be really misguided to say that's the best way and that's the only way to write the code. There are times when functional style is good. There are times when I would rather not write code in functional style, especially when I have to deal with exceptions or impurity. And here comes, I think, the biggest change in Java yet the world is going to appreciate. So if you ask me, what's been the biggest changes in Java over time? Java 5? Since the release of Java, Java 8, Java 9, if you're a fan of modules. But I'm going to say Java 19. Because what's going to happen in Java 19 is the structure of imperative style asynchronous code in this particular case will be or is the same as the structure of imperative style, again, synchronous code. And of course, thanks to Project Loom. And I think this is going to be huge. And we are probably going to take a few years to really realize and appreciate this. And to me, that is huge in terms of reducing complexity for us, the programmers, where we are able to write the code in a way we can reason and then come back and change it, but very minimally, without altering the structure, only but if and when we need a different performance behavior. And I think that's absolutely what we really want to do, because you want to really separate the logic from the implementation. And that becomes a lot easier to gauge on the reasoning of the code and then come back and improve on its performance, but without having to alter the code. And I think that's going to be really, really huge in terms of where we are going. So this is one of the reasons why the agility really matters in this case, like I mentioned, because many talk about doing agile, which is terrible. But I'm going to say Java is being agile, and I think that's absolutely brilliant, phenomenal, and we all tend to benefit from that, and I'm very thankful for that. So it's very refreshing, and I hope you will enjoy the journey as well, as much as I do. Thank you so much for joining.